Hello everyone, this is a quick audio test. Hello everyone, this is a quick audio test. Okay, hopefully things should be behaving. We should have the screen showing properly and you should all be able to hear me. Assuming there are any of you. Okay, so today's goal is to have a look at the Remote Asset API, which is kind of like the next stage with respect to the CAS. The Remote Asset API, as described in its protocol, is a mapping from some kind of URI and set of qualifiers for that URI to digests that live within the CAS. Beyond that, I don't know an awful lot, so we're going to be learning as we go. I'm going to be using the CAS Play codebase for now and implementing it against the CAS Play CAS, because having one consistent code base for doing this work in just seems like the right idea to me for now. If we get reasonably far with this and we start to do clever stuff, given that we can see here that they're talking about Git repositories and tarballs and all sorts of things and subdirectories, we might need to split it out into a separate piece of code. But for now, we're just playing. We're getting to understand what this stuff means, and we'll go from there. So the first thing I'm going to do is actually add the proto to our build. So let's go and find our build.rs. So we want the remote execution proto, and we also want remote APIs, build Bazel, remote asset v1, remote asset.proto. And we'll save that and we'll let that build, which will get us somewhere. And then we need to come in here and include the relevant API up here. So that was remote execution v2. So we want remote asset v1. Include the proto for remote Bazel. Build Bazel remote asset v1. And hopefully, assuming all is well, that will do the right thing. Okay, it's not exploded. We have a starting point. It's just occurred to me that I don't have a web browser window. Let me just get one of those. And that should mean that from here I can cargo doc. And we should... Come on, cargo. I updated all the dependencies before I started the stream, so this is my own fault. There we go. So we should now have build Bazel remote asset. So we've got our remote asset API messages here. Okay, so let's go back to the protocol definition and have a read. So the remote asset API is providing a mapping from a URI and qualifiers, whatever qualifiers are, and there does seem to be a document about that here, to digests. Multiple URIs can refer to the same content, blah, 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 head of a Git repository. Qualifiers are used to disambiguate or subselect content that shares a URI. In case of URIs referencing a repository, could also be used to specify a particular subdirectory. Qualifiers can be used to content matches. Qualify specifying a checksum. In cases where the semantics of the request are not immediately clear from the URL and qualifiers, it's recommended to use an additional qualifier. Resource type is provided for this. Okay. And qualifiers are key value pairs. No separation is made between standard and non-standard qualifiers. Hurrah. But we're using RFC 6648. Let's pop quickly over to qualifiers and see what they are. Standard qualifier name servers may support resource type, type of the resource, checksum, subdirectory within the resource, and then things to do with version control. I'm not convinced that this is necessarily a problem, so let's assume for the moment that we don't have to think too hard about that. Let's move on. Actually, let's just double check how they end up in the code. So we end up with a qualifier struct that just has a name and a value as a string. And what was the thing that it said? Like fetch directory request, fetch blob request. Okay. So have a look at fetch blob request. That just goes vector of qualifiers. Right, so it's not a hash map. It's a list of these key value pairs. URIs, oldest content timestamp, timeout, underlying fetches. Ooh, we're going to have to go and do remote calls. That might be interesting. And we've got instance names, so we have to do instance name handling. That's fair enough. Let's close that out and carry on down here. So it could return a retry info for when the client should retry the request. Right, so a long running request that timed out, that might be a way to deal with it. Clever, okay. Resolve or fetch referenced assets. May fetch content that they do not already have cached for any URLs they support. Should ensure the referenced files are present in the CAS at the time of the response. May cache fetched content for reuse. May support the complementary push API and allow content to be directly inserted. Must ensure fetched content matches all the specified qualifiers, except in the case of previously pushed resources, for which the server may trust the pushing client to have set the qualifiers correctly without validation. Must implement the complementary push, not implementing it must request from containing qualifiers doesn't support. May transform assets. For example, a tarball fetched by fetch directory might be unpacked. Git repository might be passed through Git archive. Okay. So let's look at the musts here and the shoulds. Because mays, I'm probably not interested in for now, so we don't care about that one. The should ensure referenced files are present in the CAS and if supported, remain available. That's relatively easy to do. Must ensure the fetched content matches the qualifiers, except in the case of pushed resources, in which case we may trust it. So we may as well just always require that the qualifier set matches. Not implementing push, must reject. Well, I think we're going to implement push because I don't fancy doing the fetches that were described above. That's a may. And then errors here we've got invalid argument, resource exhausted, unavailable, internal deadline exceeded, and presumably the same things as the remote execution API with respect to things like whether or not we believe the instance name matches. So we have fetch blob and fetch directory. Fetch blob, so we have the instance name, we have a timeout, if unset, blah, if set and exceeds, mumble. Well, we're only going to return anything that's pushed, so we just do unavailable, no. There'll be a different RPC code for not found, presumably. Oldest content the client is willing to accept as measured from the time it was pushed or when the underlying retrieval from the origin was started. Retries of fetch requests that cannot be completed, blah, blah, blah. If unset, the client should accept the content of any age. Okay, so we're going to have to honour this bit. URIs, multiple resources could fetch. should represent the same content. These may be URIs for content pushed via other mechanisms. Must supply at least one. May match any one of the supplied. And qualifiers, we've got all the qualifiers have to match, and qualifying names must be unique, so we can require that in our thing. And our fetch blob response, if it has a code other than OK, the operation was unable to be completed. Aha, so there is a not found. So we can do fetch blob response is a successful thing, but we can say status is not found. Although that's not found at the specified location rather than not present in the cache. That feels a bit weird to go with. There might be a better way. Keep going. The URI from the request that resulted in successful retrieval, or from which the error indicated in status was obtained. Okay, so we're going to have to do a code other than OK. Code OK status not found means you gave us a URI and let's say we went and tried to fetch it and got a 404. The qualifiers for that, expiry, blob digest. Fetch directory request gives us effectively the same thing. Instance name, blah, 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 qualifiers, and the response, again, effectively the same, and gives a root directory digest back. So it's a digest, not a tree that it's returning. That digest can then be handed to cas get tree. Okay. Push service. Again, I'm only going to care about the shoulds and the musts, so should only allow trusted clients. That's fair enough. Must ensure associated content is available prior to pushing. So if the associated content that's stated in the push doesn't exist in the cas, we should error probably. Must ensure the qualifiers listed correctly match the contents. Servers may trust these without validation, so I'm afraid we're going to. So this is, we may require an exact match, or we may do something else. We're going to do probably exact match because that seems like the most sensible thing for us to do. Clients can specify expiration information the server should respect. Okay, minimally compliant fetch implementation may support only pushed content and return not found for any resource that was not pushed first. That's interesting. So that's saying not underscore found. So it's saying we can return an OK with status not found. That's allowed. And we'll probably just return the first URI in the request at that point. Alternatively, a compliant implementation would choose not to support push and only return resources that can be fetched from an origin. We're not going to be doing that. And then we've got push blob and push directory. So we're not only going to have to match on URI and qualifiers and then verify based on age, but we're also going to have to add to the match whether it was a blob or a directory that was pushed. That's important. So what does a push blob look like? Instance, set of URIs, set of qualifiers, an expiry timestamp, timeout after which we should fail, fair enough. The blob digest to associate, so that's the thing we should return. And then reference blobs or directories that need to not expire before expiration of this addition to the blob digest itself. These are hints. Client may omit them. Servers should respect them at the risk of increased incidents. Mumble, mumble, mumble. So when we are checking whether or not the cas contains the content that we need in order to return a given asset, realistically, we should also validate that this lot is good. And that means essentially for every blob in this list, we need to do get missing blobs and check that. For every directory in this list, realistically, we should get tree on it, I suppose, and then fetch missing blobs. Or we might just do a fetch missing blobs of all of these things combined. It's not clear because it doesn't say... it doesn't say that these directories, that the blobs referenced by these directories are necessary. It's just some hints. Push blob response is empty. Helpful. Push directory. Same things, but a root directory digest. and a bunch of blobs. So this is all essentially exactly the same, except for whether it's a blob or a directory. So we can probably define for ourselves a type that we're going to use for our cache, which turns the qualifiers into a hash map, turns the just has the singular directory and has an enum or something for whether it was a blob or a directory. And our push directory response is empty, and that's it. Okay. I think that we can implement this relatively quickly. Of course, I've forgotten everything that we were working on before, so who knows? But let's give it a go. Capabilities. Here's a question. Is the presence or absence of the remote asset API part of the capabilities? Execution. Remote execution proto. Capabilities. Service. Should give a server capabilities response. Cache execution. Deprecation. Okay, so cache capabilities. Come on, cache capabilities. Digest functions, action cache, cache priority, symlink compressors. If I search for asset in here, no results. So the capabilities API doesn't tell us whether or not there is a remote asset endpoint. Oh well. Another thing that's worth noting is I did do a little bit of a search, but I couldn't find a client for this. So I'm afraid we're going to be implementing this almost entirely on our own. We won't have any tests other than our own interfacing to it. So I apologize for that, but there's not a lot I can effectively do right now. Right, let's go into our code. Find our server. This is our great big long server. I remember this code, this file being quite chunky. Okay, let's see if we can remember how to do stuff in here. So serve inserts the server, so we're going to have to support that at some point soon. A CAS server has an instance name, a storage backend, and an action cache instance. Play capabilities. Oh, CAS play capabilities server. See, I'm trying to remember all of this off the top of my head. CAS play byte stream service. CAS play CAS server, which. Okay, so we do that. So what we're going to have to do is we're going to have to add our remote asset instance to this. So let's have a look. What do we do for storage? So we have our storage backend trait, and we deal with all of that. Our action cache has an action cache trait. Action cache storage does all of those things. How do we instantiate an action cache instance? We give it the storage backend instance that we expect it to use. That's interesting. How do we put all of this together? Let's check the server again. So our server, we've gone create a storage backend, which is there, storage. Action cache storage does storage.makeCopy. Right. So we are expecting that we can make copies of the storage, and thus we're holding effectively a shared reference to it. Gosh, it has been so long since I worked on this code. Let's have a go. How far are we doing? We're 20 minutes in. And we might actually put Hunty keyboard for some code now. That'll be nice. Right, let's get a new module. Let's call it assets. And yes, come on, Rust Analyzer. Do your thing. Never mind. Assets.rs. Okay. Remote asset cache stuff. So we want an async trait for I'm going to steal the action cache as an example. So we're going to call it asset cache storage. Which needs to be send and sync. And we do our high-level functions in there. So we're going to have an async fn push blob. Do I want to do it at this level? Push blob, push directory, fetch blob, fetch directory. Yeah, push blob, and get action result is a real digest message to action result message, update action result, digest message, action result message to action result message. So this is basically using the high level types that actually come from the API. So we can do the same. This is going to take a borrow of self and a words. It's going to take a push blob request. Yep, that's the right thing. So it's going to take one of those, and it's going to give us back a result. Where do we get result from for action cache? We're just doing that. Fair enough. Let's just steal that as well. And it's going to be a result of a push blob response. And we're going to have an async fn push directory. Push directory request. Push directory response. Right, what's the... Let's do that much so far, because actually the push and the fetch APIs are independently implemented later. And let's have a... How do we do this here? We just go pubmod blah. Let's just do a memory. Thing, and that status is going to be tonic status. That push blob response is going to be that push blob response, and this we want to create that. So we now have this memory-based asset cache. Right, let's have a look at the action cache. So we get action cache storage instance and result. What's the action cache storage instance? So we do a pub type blah instance is a box din. Let's get that out the way now. Pub type asset cache storage instance is a box din. Asset cache storage. Type alias is never used. Sure, it must be. Private trait, so that should be pub. And then that probably shuts all of that up. Okay. So if we look at the memory cache here, we pull in those three things from super. So it's going to be use super asset cache storage instant, and result. And then here we have, so there's a memory storage which has a storage backend instance and the content, and then we need to do an impl to instantiate it. Let's do that very basic stuff so far. So pub struct memory asset storage, which will have storage backend instance, and that'll do for now. And we'll pub fn instantiate, and if we look here, we take the storage backend instance, and that takes a limit and returns a new instance. Do we want a limit for this? I don't know for now. Let's not worry about that. So it's going to take a storage, which is a storage backend instance, and it's going to return an action cache, sorry, an asset cache storage instance. And again, if we look here, that's a box new blah as. So we need box new memory asset storage as that. The trait bound blah action asset cache storage is not satisfied. Correct. So we now need to implement the storage trait. So again, we're going to async trait impl asset cache storage for memory asset storage. Come on, Rust Analyzer. Surely you can give me the magic thing. It seems to be struggling today. That's okay. We just need our async functions. So let's just grab them out of here. Copy and paste and stick to-dos in them. How far are we getting now? How have I cocked all of this up? Well, we can import the missing doodads, which will help things a little bit. Okay, so we're getting there. We're getting there. So at the moment, we're just going to do. That's not really good. We should probably actually return some kind of not implemented error. So let's see if we can remind ourselves how to do that. So we've got the unimplemented code. Status is a tonic status, which has this code stuff. Invalid argument. If I search for invalid argument, can I see examples of us generating that stuff? Yeah. Okay. So return status invalid argument. No, not invalid argument, sorry. not implemented. What is it? What's our method for this? Not found, unauthenticated. Valid argument already exists. This is weird. Where is my tonic status for not implemented? We already have a reasonable expectation that, you know, that code there is a tonic status code, and it's unimplemented. Goodness me. My brain. Status unimplemented. No push blob yet. And that's just going to be of that. Let's see if that works. Expected identifier. You don't like this? I think Rust Analyzer is just being a bit awkward today. Let's try and force it through. Okay, let's cargo check. You see? That's just, goodness me, it's just Rust Analyzer being strange. We'll deal with it in a bit. Let's keep trying to wire up the service, shall we? So, our next thing is to add the playcas server. Yeah, so let's take that, yoink it down here. Okay, but it's not a playcas server, it's a play asset push server. Is that fair? Just do a play asset server, because we'll implement push and pull from it. Yeah, that'd be fine. No. Yeah. Play asset push server. Goodness me. Which has a mutex, and cas server is just our core cas play server thing. So we now have that. Let's see if I can remember what we have to do for it. We want at minimum there's no check the instance there, but we'll get there. Steal the code, play asset push server. All those should be right. Yep. And then we're going to async trait impl that for play push server. Okay, so async trait impl, and what did we think it's called, the service? It's just going to be push, isn't it? It's just called push. Push, which is that. For play asset push server. Right, that's going to complain that we're missing push blob and push directory, which of course we are. So what do they look like? Push server, push. Actually, I should just double check that we actually got that from push server. We did, good. Okay. So we've got push blob, push directory. In each case, we get a request of the right thing. And in each case, we are going to return a result of a response or a status. Impl push, sorry. fn push blob self request, which is a request of a push blob request, and it returns a result of a push blob. Well, it returns a result of a response over push blob response or a status. See if it's happy with that. Lifetime parameters or bounds on push blob do not match the trait declaration. What have I moosed up on that kind of thing? Async. That's what I've messed up on that. Right, and now we're just missing push directory. Async fn push directory. Taking self. Result. Response. Push directory response. Status. So we've got those core bits in. Now we need to wire it up. We wire it up here. Let asset storage equals. So we're always just going to do a memory asset storage for now. It doesn't really matter. Eventually we might want to write a disk storage, but I'm not going to faff for now. So memory asset storage, taking a storage, make copy await. So we've now got our asset storage as boxed in asset cache storage. That's fine. Asset storage is going to go into the server, which is going to whine that it wasn't expecting it. Assets is an asset cache storage instance. Assets. Right, so that's got as far as structuring it all into place. Now we need to add the service. So add service. Push server. New. Which takes a play action cache on our clone of server. Am I doing the right thing? What am I missing? Trait bound push server push is not satisfied. It's not implemented for play action cache. That's because that should be a play asset cache. Or play asset push server. That's happier. So we've layered all of the service up. Okay. Let's see where else we can get to. I was going to say, should we write a client for this? But let's keep wiring up at least until we get to the not implemented of the back end. Then we'll try and write a little client and we'll see what we get from there. So we have our to-dos here and we want to wire them through to the back end of the server. So we need to check the instance name. So let's do that check. It's nice and simple. Let me get rid of this search. It's annoying me now. And then if we've got this far, we get to pass it on. So the way that these things do it is they acquire all of the bits and bobs, and then they take the server, they stick stuff into it and await. Given that we've said we're just going to pass the raw requests and get raw responses back out, let's see what we can do. We could do self.server.await.push_blob, handing it request.into_inner. Question mark. Await, question mark. So now we have a push blob response. So we do OK response new. That, so OK response new of res. I could wrap that whole thing in it, but that's just a little easier for my brain to track. And if I just copy paste that entire thing into there and change that blob for directory, again, that should compile. Okay, so at this point, we've wired up the push service to our server. We've implemented these here. We've wired that up to a nominally dynamic dispatch implementation of the asset cache. And we've written a trivial memory cache that should just say no push blah yet. So we've got an implementation, and unless I'm mistaken, that will build. And it is. I mean, it would have exploded by now if it wasn't. So we now want to try and have a client for this. I don't know if you remember, but most of the client functionality is just in the casplay bin, because that's what we do, because we're being really cheap. And we had capabilities fetch, upload, list, and serve. So we're also going to add a command which I'm going to call asset. And I'm going to say that takes an asset data. And now let's parser enum asset data. And there's going to be push, which takes an asset push data. And we're going to derive parser and debug on a struct asset push data. And that's going to have clap, long, short equals D directory bool and digest. Oh, we need, digest string. So that gets us most of the way to what we care. So expected a car, found a string. That's fair. That should be D. You're going to have to specify URIs. Clap long URI vec of string. Do we want to specify that you need at least one of those? Yes. Min values 1. That wasn't a bad guess, was it? Asset data clap args is not satisfied for asset data. That probably wants to be subcommand then, rather than parser. Trait bound is not satisfied. Oh god. Okay, fine. We're not going to do that. We'll have push asset, which takes an asset push data. That should shut that up. And then here, we're going to want a command push asset data. Oh god. To do. Just to verify that whole thing. Builds, and now we should be able to go. Do I have 2 directories? I do, right. So cas, so cargo run dash dash serve. Okay, so cas play is running. And then here I should be able to go cargo run help and get told that there is push asset, and push asset doesn't get given everything it needs. You need to specify URIs. So if I said push asset 1234/1234, which is a digest, we get to the not implemented. So that min values 1 certainly didn't work. Let's do no, I really want at least 1 URI to be specified. I have no idea how that's not working, but I don't care for now. I'll just error out if it's not provided. It'll do. So we're going to do push asset config data await, and push asset has to smell it's an async fn taking a borrow config, push data, and returning a crapshoot. Okay, and how do we just go boom with a crapshoot? It's anyhow bail, right? Anyhow bail. Whoa, push. Go again. Okay, we're getting there. I said I wanted at least 1 URI, so if data.uri dot is empty, at least 1 URI must be provided. We should add support for the qualifiers. So we're going to go qualifiers we'll do as key value pairs, but we'll do it with equals in our code. So for qualifier in If qualifier fired, if let some key value is qualifier dot split once on equals, else invalid qualifier, correct form is key equals value. So if we push, insert. That will insert it, and if qualifiers dot contains key bail repeated qualifier key. So that gets us to the point that in theory we can issue the request. And if it's a directory, then -d will have been specified, and we'll go from there. Okay. So we need to construct our request, and that will depend on whether we're pushing a directory or a blob. We need to convert the incoming digest into an appropriate digest first. If let some hash comma len is data dot digest dot split once on slash else Okay, so we've been given a hash and the len has to become an appropriate, whatever, so it's I64 or something like that. So we can go okay, let so digest hash colon hash dot to string size in bytes len dot parse question mark. Can I do that? Expected a semicolon. We're getting there. Cannot borrow qualifies as mutable. Okay. Woo! Goodness me. So we've got a digest. We know the instance name from the config. We know where we're connecting to. We've got whether or not we're a directory. I think we're there. So we can connect to the server and do the thing. So let's grab a connect to server thing. Mute. So it's capabilities. So client connect. Endpoint clone. Right. So server equals push client connect config endpoint clone await. That gets us a push client channel. We then want to go if data dot directory else. Right, so we're a directory, so let's construct a push directory request. So request is push directory request, and fill in the fields for me. Okay. Instance name, that's going to be config dot instance name. The URIs is going to be data.uri.clone. The qualifiers are going to be into iter map given a key and value. We want you to produce a qualifier of name is key and value is obviously value, and we can collect that. Expire at, okay, can't find key and value, that's K, and so value is V. How are we doing? We're getting there. So expire at is going to hopefully be an option. Let's double check that. So a push directory request. Yeah, so expire at is an option. Root directory digest is an option, although blah, and then reference blobs and reference directories are empty vex. So that's a none. The root directory digest is some digest. The reference blobs is an empty vector, and the reference directories is an empty vector. So we've constructed our request. We now need to make the call. The call is going to be, so res is server dot push directory, which takes a request. We await it, we question mark it, and we've got a push directory response, which we then have to deal with. So let's remind ourselves how these things work. We can just into init and unwrap it, but in reality we want to check the code that's come back on that response. So let's remind ourselves what one of those looks like. So we're doing a push client, doobie-doo. Response is a tonic response. Does that give us a code? No. Oh, right. So if the code is not okay, we're not going to get here. So what we can actually do is just, if we got here, the push succeeded. So there is no useful push directory response. The push directory response is an empty struct. So we're done. Which, okay, it's not delightful, but fair enough. Expected result, bar error found. Really? Oh, so this is returning a crap. Of course it is, yeah. It's okay. So, cannot borrow server mutably. Let's stick a mute on there. Unused variable. I mean, in reality, we don't even need that. We can just let it get dropped immediately. Right, so let's do the same for a push blob. Push blob request. Push blob. And it's just going to be blob digest rather than... So push blob request comes from there. And it's just blob digest instead. Okay. So we've got a basic client in place that lets us push stuff. So step one, let's push a blob. So cargo run dash dash upload. I don't care, build the RS. So this will put a blob in the CAS that we can then use. Transport error. Are we defaulting to build grid? That would be annoying. Dash dash upload. Upload. Yeah, we default to build grid because of course we do. Well, never mind. Let's just do that. So this is our build RS blob. So I'm going to do build RS equals that, just so I can do $build RS whenever I want to upload or reference it. So run push endpoint that push asset. Give me some help. Okay. So we want to say it's not a directory, it's a blob. That's fine. Should we give it a qualifier of some kind of MIME type? So if I remember correctly, there was a specific qualifier name that's effectively the MIME type. Is it resource underscore type? That's the implication there. Let's just double check the qualifiers.md. Describes the type of resource. File assets should use an existing media type. Yep. So let's specify resource type is text plain. We want a URI of that, and the digest is that. So we ran resource type text plain, URI that, digest that, and we got unimplemented no push blob yet, which is absolutely what we expect. Give ourselves a prize. Okay. Close the proto for a bit. I don't think we're going to need to do a lot more in that for now. So let's move on to our incredibly trusting asset cache storage. Okay. Step one, let's get a little bit of tracing in here. So remind ourselves how to do that. So there was a message that we saw, which was handling write for. Handling write for is just an info pling inside a function. Okay. Let's go into our server and do that here. So it's going to be no, let's not. Let's be ridiculously thingy, and we'll go. Can I instrument? I think instrument skip self. Is that right? It's looking good. Let's stick that on both of those. And let's run that command again. Oh, hang on. We need to rerun the server first. Server's running. Run the command. No instrument. Oh, we might actually have to execute like an info or something in there before we get there. Okay. In that case, instrument is less interesting. Maybe, maybe not. Let's remind ourselves of what an asset key looks like. An asset key is a URI, whether or not it's a blob, and the set of qualifiers that apply. So let's define a type for an asset key. Okay. Struct asset key. So I said it's URI. It's whether or not it's a directory, and it's some qualifiers. Now, if we kept them in a vector, it would be quite sucky, but they're just key value pairs as strings, so we could swap them out for a hash set of qualifier, which could be a nice way to do things. Now, asset key is never constructed. That's fair enough. Let's derive. So what do we want? We'll get debug just in case. We're going to want partial EQ, EQ, and hash. And that's almost certainly going to tell us that qualifier doesn't implement those. I do remember this thing happening. So if we go to build.rs, we added EQ and hash to digest. And we're going to do exactly the same thing for remote asset v1 qualifier. Stud collections hash set blah stud hash does not satisfy the trait hash is not implemented for hash set. What? I can't hash a set? Well, that's no good. What am I going to do? What am I going to do? Why does hash set not implement hash? Is there some constraint on that? Let's have a look. Hash set. Trait implementations, auto trait implementations. It's just going to be a billion hits for that. So it implements EQ for hash set, where T is EQ. That's reasonable. Yeah, there is no impl hash for hash set. Well, that's a big pile of pants. What should we do instead? We could do a vec of qualifiers. And then we could sort the qualifiers before we insert them, when we construct the asset key. Let's do that. Vec of qualifiers. That will work. And an asset value is just the digest that we're going to return. And for now, we're not going to do the expiry or any other crap like that. So our memory asset storage, as well as having a storage backend instance, is going to have some data. And assuming that I have remembered correctly, I'm going to need to put that in a mutex. Yeah, so it's an arc of a mutex of whatever we're going to do. So we're going to go, the assets are an arc of a mutex. That's going to be a Tokyo mutex of a hash map from asset key to digest. It's probably going to complain that it doesn't know a bunch of things. So arc is a stdsync arc. Hash map is a standard collections hash map, and digest is a write execution digest. And self is now missing assets. And assets will be an arc new of a mutex new of a hash map new. And we're back to compiling but not having the relevant content in. Okay. Right. Let's have a little think having the relevant content in. So pushing a blob, we need to transform this into a number of asset keys, one for each URI. And then we need to insert those into the hash map. I think we'll write an impl asset key that generates the list of asset keys for the push blob request. So let's do that. Impl asset key. Fn generate, which takes a request, which is a push. Oh, push blob request and push directory request. They literally only differ by the name of the digest field. So I'd rather not faff like that. Let's actually decompose the request and pass in the stuff that's needed. So there's going to be a URIs, which is a vec of strings. There's going to be directory, which is a bool. There's going to be qualifiers, which is a vec of qualifier. And there's going to be a digest, which is a digest. And it's going to return an impl iterator where the item type is a tuple of asset key and digest. Let's see whether we're getting somewhere. Bracket is not blah. Iterator is not implemented for unit, but I've got a to-do in there. Oh, I've got double parentheses, and I think I don't need that. Return type in what? Not implemented for. Let's leave that for a sec, and let's write push blob and push directory. So digest. So push blob request. Blob digest. URIs and qualifiers, and everything else is request. So let's destructure just the bits that we want out of the request. If let digest equals blob digest dot okay dot map error as status invalid argument missing digest. So we should be getting somewhere. No method okay for stud option. Oh yeah, okay. Or else. Status argument. Okay, That's got our digest, we've got our URIs, we've got qualifiers. We're going to assume that the qualifiers are good, so we're going to sort them. So let's say qualifiers dot sort unstable. Okay, what are we missing? We're missing odd and partial odd. So let's go and re-add those here. So we want add those to the build RS. Wait for it. We should be good. And now what we've got is essentially an iterator of asset keys that we want to use to extend the hash map that we have in ourselves. So we are going to go self.assets.lock await. Let assets equals that. That's a mutex guard, so if we make it mutable, then we get to play around with it. And then we get to go assets dot extend with an iterator, and that iterator is going to be asset key generate with URIs false because it's not a directory, the qualifiers and the digest. And okay, push blob response empty. Has that behaved itself? I think it might. So let's do the same for pushing a directory. So instead of a push blob request, it's a push directory request. Instead of a blob digest, it's a root directory digest. The digest then becomes root directory digest dot that. The directory is true at that point. And it's not a push blob response, it's a push directory response. So we've got all of that happening. Now we just need to implement our iterator for this. So it's going to be uris.intoIter.map. Given a URI, what do we want? We want an asset and a digest. Okay, so we want an asset key with URI directory, and qualifiers is qualifiers.clone, and digest.clone. And URI.clone. Closure may outlive the current function, but it borrows digest, which is owned by the current function that may outlive the borrowed digest. Move. Yeah, so that at that point is redundant. We can get rid of that. Woo! We've got somewhere, right. Do we want to... Yeah, why not? And we're just going to DBG that, because that way we'll get to see what's going on. Okay. Let's restart the server. Then we need to because we should be using a memory cache by default. We then need to upload build RS, and then we need to try and push a blob asset. So that's succeeded. And if we come over here, we can see that what was inserted into the system was that URI, that it's not a directory, and its resource type is text plain, and it's this digest. So that's working. We can probably switch that out for, instead of doing a dbg over that whole thing, we can probably go, you know, info, upserting for URI. It's probably going to play it can't find info. We're going to import info from tracing. And let's get back to the server, kill it. So we're not doing any of the checks at the moment, or, you know, anything like that, but that's okay. So let's do the upload and push the asset and come over here. And we've actually got a reasonable thing now. So we've got a push blob where that was the push blob request, and we are upserting for that URI. And if we'd specified multiple URIs, we'd get an upsert for each different one. So we now have push blob and push directory implemented. Give ourselves a pat on the back. Hurrah! What we've not done, like I say, is any of the specific checks that we should be doing. And realistically, they should be happening in here in this code. So, you know, realistically, we should say to do add all relevant checks, e.g. is content in CAS, are qualifiers sane, etc. And we can take a copy of that to do, and we can shove it there as well. So that's reminding us where we want to put those checks. So the next thing for us to do is to write the fetch blob and fetch directory stuff. So let's come and add our async fn fetch blob, which is going to take a self, a fetch blob request, and is going to produce a result of a fetch blob response. And similarly for fetch directory, and now it's going to complain that those aren't implemented for our storage. That is fair. I'm going to get rid of the instruments just because they end up with those really big messages. And let's do an async fn fetch blob. Fetch blob request. Async fetch directory. Okay, so let's implement the fetches. In this case, we need to extract the same information. We need to do the same sort. We need to generate the same set of asset keys, except that we don't have digests this time. So what I'm going to do is I'm going to write, let's have a look, let's have a think. So generate keys, which takes URI's directory and qualifiers, and gives back an impl iterator where item is asset key. And let's actually just do this. It's going to be URI's into iter map. Move URI Asset key, URI directory, qualifiers, clone. That's reasonable, and then we can re-implement this. It can be self generate keys, all of those, map a key to the key and digest clone, and that will need to move. Okay, so now we have that separated out. We can start to do our thing. So fetch blob request of URIs, blob digest and qualifiers is rec. So fetch blob request doesn't have a blob digest for obvious reasons. So URIs and qualifiers. It's going to be mute qualifiers because we need to be able to sort them. And now what we want to do is basically for key in generate keys from that. And our state here is it's an error and it's a status not found. Unable to find any matching asset. Matching blob asset. And the key variable in this context is an asset key. So now what we can do is we can start to look for it in our cache. So we can go let assets is self assets lock await. If let sum digest is assets dot get of the key. We found a digest. We want to return it. So we need to generate our fetch blob response and return it. So it's going to be return OK. Fetch blob response. And let's see what we need to fill in here. Status is going to be, oh gosh, what is it? Status is meant to be an option of, that's presumably a gRPC status. Let's double check. Fetch blob response. It's an RPC status. Okay. So that's going to be some RPC status of code message of nothing and details of none. Expected a vector, so it's an empty vec. We're all good. Right, so the URI is key.URI. The qualifiers is key.qualifiers. is key.qualifiers. Expires at is presumably an option. Yes, none. And the digest is some digest. How are we doing? Expected, struct, blah, remote execution, digest, found borrow of. Yep, some digest, clone. Right. And unfortunately now this is essentially a copy pasta for the directory request, where we need to replace that with directory. We need to generate keys with directory true. We need to generate a fetch directory response, which needs a root directory digest, and unable to find a directory asset. Whew. Right, in theory, that's a basic, completely trusting blob fetch and directory fetch. So let's come and write the play asset fetch server. And again, you can guess that we're going to want to just steal that whole thing. Fetch. And fetch. And we're going to import fetch, which comes from right asset. For play asset fetch server. It is an async trait. And it's going to complain that fetch blob and fetch digest aren't implemented, but I can't get it to do it. I think async trait is messing with Rust Analyzer at this point, which, you know, is frustrating, but it's the way it goes. Async fn fetch blob, which takes a self, and it takes a request, which is a request over a fetch blob request, and it gives us back a result over response of fetch blob response and status, and is to do for now. And if I take that entire thing and paste it again and do fetch directory and directory and directory, then we are getting there. Get me that and that. Right, and again, let's just yoink all of the things that we want and just do this trivially here. So we don't want to push directory, we want to fetch directory. And instead of that to do being there, it belongs there. If we successfully fetch something out of that cache, we should validate that it makes sense. And now we can cargo cult that up here. Obviously that becomes a fetch a blob. All of that is compiling, so now we come up to the top here, and we once again add a service. Fetch server new of a play asset. Fetch server new of an arc. Clone of borrow server. That's all behaving. So we've now got a server that we can fetch from. So now we want to write fetch asset, because we wrote push assets. Now we want to write fetch asset in casplay. Woo! Isn't this fun? Okay. That was asset push data. So let's do our asset fetch data. And the critical thing there is that we don't want a digest. And we don't need the URI stuff to be optional because you just specify some number of URIs. And we need fetch asset, which is an asset. Fetch data. And CLI command is going to need command fetch asset over data gives us fetch asset with a config and the data. Whee! Async fn fetch asset, which takes a config and some data. And is a crapshoot. Oi, okay. Need all of this because that's basically the same. We need our server. Endpoint clone. So that gets us our fetch client, and then if data.directory. Request is a fetch directory request. We then do res is server.fetch directory of request. And we'll stick a dot into inner on the end there. And then we can say res.root directory digest dot okay or else anyhow bail. Actually, I can just do it okay or wah. Are we there? Missing structure fields, trait bound. Okay, fine. Anyhow, bail. Oh no, it's anyhow pling, isn't it? Cast play remote execution v2 digest doesn't implement display. Oh, for pity's sake. Fine. There we go. Right. So we just need to add the important struct fields. So instance name is going to be config instance name clone. Timeout will be none. Oldest content accepted will be none. URIs will be data.uri.clone. Qualifiers will be qualifiers dot into map AV qualifier name K value V collect. It's not self there, it's config. Else And let's do the same for a blob. So that becomes a blob request. We fetch blob. The digest is blob digest. And that should all just fall out in the wash. Except, of course, we cannot find fetch blob request because we need to import it. Use of OK or followed by a function call. Yes, that's fair. OK or else that. Okay, right. So let's get a new server going. Okay, let's now upload build RS. Let's push the asset. And now let's try to fetch an asset. We don't need -u. It worked, it's just I left a to-do in because I'm an idiot. That to-do should just be okay. Let's run that again. So that worked. Let's, change the name of the file, and we get a not found. Can't find any matching blob asset. Goodness me. We have, I believe, done the most trivial set of implementation. I don't really want to start writing the checks because we've been at this for well over an hour and a half. So I'm going to commit this and we'll call it for today. Let's have a look. Let's just first of all have a quick look at what our warnings are. So we've got some unused imports. Let's get rid of those. We're not using that anymore. And we never read the storage because we're not actually checking things. And in reality, we said that we wouldn't. We said that we'd check stuff in the outer space. But I suppose we want this because we might then want to forget asset. No, we might actually end up having to write the checks in here. I'm going to stick an underscore on the front of that for now, because you never know. We might want it, and we can always think about it again next time. So we've got rid of our warnings and lints. Git add initial asset cache implementation. Pretty dodgy. There you go. That's now uploaded so that others can play with it. I hope that this is interesting for you. Thank you very much for watching.